All right, so good morning. This time around, I want to discuss something about the characteristics of inductance, okay? Now, inductance is measured in Henry, okay? Henry. So if you're, given a circuit, where you have, some capability to have inductive impact, and you have a way to change the current in some manner, and I generally show alternating current, but you can have many types of current. So you have this situation, and this inductor, when it is exposed to a time varying current like this, di by dt, and the flux which gets generated gets associated with this, and that flux is d phi by dt, okay? Now, the inductance, the inductive, that shows the inductive effect of producing EMF. So when voltage is produced here to oppose the applied voltage, right, that is called as the inductive effect. But remember, the inductance of a circuit is a constant quantity, which means if you increase the rate of change of current, okay, you double it. What you will see is that the voltage which gets produced in response to doubling of rate of change of current also doubles. So L is a constant. So the voltage, which is because of the inductive effect, is proportional to di by dt. And this is something which is pretty well understood, that this is a constant, and the proportionality sign is to be reduced, and let me just do this. So the voltage produced in the inductance is this. It is proportional to the rate of change of current, so which means V is equal to L di by dt, okay? Now, L is a constant for a circuit. You cannot change, the inductance or the inductive effect being seen in this particular coil. So this is a coil, and so which means if you double this, quantity, your voltage will also double. Okay? Which means L, which is in Henry's, here we're discussing self-inductance because we have one circuit which is opposing the applied source of EMF. So this is self-inductance. But the voltage which is getting generated in this, which is here, the voltage, and this could be momentary voltage because of momentary change in current. It could be continuous because of application of an alternating current. That depends. But the point is, the inductance of the circuit is a purely constant quantity and is purely a geometric quantity. The only way you can change the inductance, for example, in the case of self-inductance, is maybe you increase the number of turns, okay? So increase the number of turns, and maybe you have more inductance. Increase the length, okay? Change the area, okay? The area. So it's a geometric quantity. Only geometry can change it. The rate of change of current will result in production of a corresponding voltage. The ratio will always remain same. So the only way to change inductance is work on geometry of the inductor and change it. Thank you very much.